Welcome back. If you spend the next 8 minutes watching this video, I'll help you to understand enzymes better, helping you to score better marks in exams. I've also made you a little quiz at the end so you can check how much you've understood. If you're new here, welcome to BioSmash. I'm Jo, I'm a science teacher. I'll help you smash your biology revision. As you're watching this video, your body is busy carrying out loads of chemical reactions. For example, it might be breaking down a slice of pizza that you ate for lunch. Pizza contains long molecules of carbohydrates, long molecules of protein, and molecules of fat. Your body will need to carry out chemical reactions to break these big molecules down. As you'll know from science lessons, to get chemical reactions to go faster, you need to increase the temperature. However, the human body has to stay at 37 degrees C. This means the body needs another way of speeding up chemical reactions. So, living things contain enzymes. Let's have a look at what enzymes are. I've labelled an enzyme in this diagram. Enzymes work a bit like scissors. They find large molecules like this protein and break it up into smaller molecules, like these amino acids. We can look at that in more detail. The purple shape is the enzyme, which acts a bit like scissors. The blue shape is a molecule that your body needs to break down. The enzyme breaks the bond between two of the atoms in the molecule. If you look closely, you can see the bond has now been broken. This means that the first atom in the molecule has now been freed and can move away. Here's a different diagram of an enzyme. I wanted to show you this so you understand that enzymes can also join molecules together. They don't just break molecules down. We call enzymes biological catalysts. This is because catalysts are chemicals that can be added to a reaction to speed the reaction up, but the catalyst isn't actually used up in the reaction. So if you need a definition of enzymes that you can learn and remember, you could write down that enzymes are biological catalysts and they speed up chemical reactions without being used up in the process. Let's look at an example of a reaction that's carried out by an enzyme. Proteins are broken down into amino acids. We write the word enzyme above the arrow to show that an enzyme is needed but isn't actually used up in the reaction. At the end, we'll still have the enzyme, but we won't have the protein. We'll have amino acids instead. Sometimes, instead of writing the word enzyme above the arrow, the scientist will write the name of the specific enzyme that carries that reaction out. And you can usually spot enzymes because they end in the sound ase. The enzyme that breaks down proteins is called protease. You see what they've done there? And you might be able to guess that the enzyme that breaks down carbohydrates is called carbohydrase. Sometimes we call fats lipids, and the enzyme that breaks down lipids is called lipase. Give this video a thumbs up if you're starting to understand this topic better. Let's look at how enzymes work. We often call the molecule that fits into an enzyme a substrate. The part of the enzyme that the molecule fits into is called the active site. You can see that the shape of the active site fits really well around the shape of the substrate. Just like your key fits really well into your lock and just your lock. This is called the lock and key model. We say that each key is complementary to one lock. Your key will open your front door, but it won't open anyone else's. In a similar way, we say that the active site is complementary to the substrate because one substrate will fit into the active site of one enzyme. Each enzyme has its own shape and will only fit one particular substrate. In addition to the lock and key model, there's a second model of how enzymes work. This is called the induced fit model. To help us understand this model, we can think of a pair of gloves. When you put on a pair of gloves, the shape of the glove changes to fit around the shape of your hand. In the induced fit model, the shape of the active site doesn't exactly match the shape of the substrate. But as the substrate binds to the active site, this causes the shape of the active site to change as it fits around the substrate. And this process is thought to put extra strain on the bonds between the molecules, helping them to break. I really hope you're finding this video helpful. If you are, then please do click subscribe. It will help you to find my other videos. There are lots of different types of enzyme, and each one only carries out one specific reaction. Let's look at why that is. Here, there are 3 different enzymes. We say that each one is specific to one particular reaction. You can see that the shape of each enzyme's active site is different and will fit one particular molecule. Each enzyme's active site can only fit the particular substrate that that enzyme is needed for. This is why enzymes are so specific. This is really helpful for the body because the body can turn on one particular reaction by producing more of one particular enzyme. Let's look at what happens to enzymes when we change the temperature. To help us understand what happens to enzymes as we increase the temperature, let's look at what happens to this egg as we heat it up. Can you see the outer part of the egg changing? The part of the egg surrounding the yolk is made of protein. As we heat up the egg, this changes the protein in the egg and they denature, they change their shape, and this is why the egg changes. Now let's look again at our group of enzymes. So at the moment, the active site is complementary to the substrate, so the enzymes can carry out their reaction. Now let's increase the temperature. You can see that the high temperatures have changed the shape of the enzyme, and this is because the enzyme is made of protein. We say that enzymes denature at higher temperatures. Because the enzyme's shape changes when it denatures, this changes the shape of the active site, so it's no longer complementary to the substrate. This means that the reaction cannot continue. Here are some sentences to help describe this process if you want to write them down. So as temperatures increase, the enzymes denature. This changes the shape of the active site and it is no longer complementary to the substrate. The rate of reaction decreases. Just pause the video now if you want more time to write that down. It's time for our quiz to check how much you've remembered and understood. I will show you some statements. For each one, you have to decide if it's true or false. Question 1, true or false? Enzymes are made of carbohydrates. The answers come in a second, so pause the video if you need more time to think. Just to mention, I'm developing some resources to go alongside these videos for those who'd like a little bit more support with their revision. If you're interested, check out the link to the online shop below. That statement is false. Enzymes are made of protein. Statement 2, lipase enzymes cannot break down carbohydrates. So if you've got lipase enzyme, is it true that it will not break down carbohydrates? True or false? And the answer's coming in 3, 2, 1. That one's true. Lipase enzyme breaks down lipids, carbohydrate enzymes breaks down carbohydrates, because remember each enzyme is specific because its active site is a different shape to match one particular substrate. And finally, all enzymes denature at 40 degrees. Is that true or false? So 3, 2, 1. This one's false. It's true that many enzymes in the human body might denature at around 40 degrees C because this is slightly above body temperature. However, there are other enzymes in the world that will not denature at 40 degrees C and can actually keep working at much higher temperatures depending on what environment they find themselves in. How did you get on with those questions? Put your score in the comments below so we can see how well you've done. If you feel you've got the hang of this topic, you might like to check out this video next. And I hope to see you again soon or smash some more biology revision.